one good question by email about the discussion of objects movement with the displacement and velocity, so position, velocity, and how do you know if something's moving away or towards the origin. So I'm just going to kind of review that. And if it's moving away, so imagine your number line, there's your origin. If you had an object that was moving away, you're going to have two options. So if the object is over here, and I'm going to call that S is greater than 0, so its position is somewhere in the positive side. If you want that object to move away from the origin, it's going to have to go that way. So that would also be velocity is positive because it's moving in the positive direction. If the object was on the other side, so if the object is in the negative section, so if your displacement or your position is less than 0, if you want that object to move away, it's going to move more in the negative. So the velocity would also be less than 0. So if the object is moving away, we know that the S and the V, those signs match. And kind of the opposite of that, if it's moving towards the origin, depends where it's located, what you need its velocity to be doing. So say you had your object in a positive position, so its S value is positive. If you want that object to move towards the origin, it has to have a negative velocity. And the opposite situation is true. If it's got a negative position, so S is less than 0, then it would have to have a positive velocity. It would have to move in the positive direction to get towards the origin. And of course, this doesn't last for forever, right? Eventually, you're going to move this positive velocity, and now all of a sudden your displacement's not negative. This is just at this moment in time. Is it moving towards? If it's to the left of the origin, your displacement or position is negative and velocity is positive. Yes, at that moment, it's moving towards. So here, the displacement or position and velocity signs are opposite. And you may have to show that a number of different ways. For instance, like if you had, let's say a function, you were given S at t is, I don't know, x squared plus 4x minus 10. And then you can find your velocity, that this would be 2x plus 4. So let's say at t equals 1, is it moving away from or towards the origin? So you would say S at 1 would be 1 squared plus 4 times 1 minus 10 is going to be negative 5 meters. And V at 1 is going to be 6 meters per second. So this would be opposite signs, so it's moving towards the origin. At t equals, say, 10, oh, that's going to be big. I'll use a calculator. You would just figure out S at 10, V at 10. So this would be 24 meters per second. And, oh, this isn't so bad. 100 plus 40, take away 10, you get 130 meters in the positive direction. So the signs match, so it's moving away. You could also have to look at, say, where is it, positive or negative, and then you'd have to kind of consider the zeros and look at, say, the intervals from 0 to a number, and you just kind of say, okay, and these would all be the zeros. So you'd look at like the intervals where those are 0, and this example isn't that good, and just kind of compare. Are the signs the same? Then it's moving away, or are the signs different? Then it's moving towards the origin. You could also have to take a look at this from the perspective of a graph. So if you had this, and this was your displacement position function, and we've got, I don't know, some graph like that. So we know that the derivative is the velocity. So if you looked at a certain point on the graph, like there, I know that point is positive. The y value is my position. That's positive. But the rate of change at that point, the velocity is the slope of the tangent. So the velocity has a negative slope for sure. So this is moving towards the origin, which should make sense from this graph. I think graphs for these ones are easier because that's the origin, the yellow. And if you trace along here, yeah, it's going closer, right? It's getting towards the origin. Okay. At another point, it might be different. So here, the position is negative. It's in the negative side, and the slope of the tangent, or the velocity, is also negative. So in this case, it would be moving away. Which, again, that's what's happening, right? If you are at this point, you're getting further from that zero line. You're going further. After here, now my velocity is positive because I've got positive slope. Now it's moving back towards. Oh, now my position's positive and velocity is positive. It's moving away, away, away. So hopefully that helps clarify that a little bit.